Welcome, everybody. So this is a panel on the future of work and education in data. Thank you all very much for being here. Today in this panel, we're pleased to welcome Dr. Mustafa Bilgic, who is an associate professor and the director of Masters in Artificial Intelligence and BS in Artificial Intelligence programs. He's as well the director of Machine Learning Laboratory in the Computer Science Department at IIT. We also have with us Dr. David Uminsky. He's the executive director of data science and a senior research associate at the University of Chicago. He was previously an associate professor of mathematics and executive director of the Data Institute at the University of San Francisco. Finally, but certainly not the least, we also have with us Jonathan Williams. Jonathan is the director of curriculum development at Trilogy Educational Services, a U2 Inc. brand, where he leads the design and development of technical learning content in the data discipline. Welcome, gentlemen. It's a pleasure to have you on today.
Pleasure to be here.
So we're going to conduct this in a very, very informal sort of way. And we're just going to have discussions. It's about thoughts, minds, opinions, and challenges, right? Let's talk about some good stuff. And without further ado, let's jump into the first question. There are times when I actually pinpoint people to talk about certain things, but please feel free to jump in and give your opinion, right? Let's start with the first one. What are your core, what's a core vision that drives your beliefs in terms of a data science or data related education?
To solve all of our problems, to solve cancer, COVID, everything, climate change.
Right. Yeah.
Joking aside, obviously, we want the data scientists to train to be able to handle challenges that we face as a society. Like these challenges linked with medical challenges, financial challenges, the challenges about connecting people, maybe, fake news, misinformation. I mean, there's a lot of challenges that we face that hopefully most of these problems can be dealt with data. Some of them are created by data. So I think we are envisioning data science who can develop, address these challenges, but also understand the weaknesses of the methodologies, right? Sometimes we see this data science as a hammer and everything looks like a nail. So we want the data scientists to understand the weaknesses of these methodologies so they know when to apply which methodology. That's how I would actually at least start.
Oh, very well put. That's a very good opening statement. Anyone else thoughts?
Yeah, I agree with what Mustafa said there. I think here at the University of Chicago, the vision for our education around data science is developing, but there's some very important decisions that we made very early on as we begin to roll out new education programs in data science. One is there's just a foundational grounding in computation and statistical reasoning that just has to be there from the onset, but it doesn't stay there. Right from the core of our education, we do need to make sure that students understand some of the important things Mustafa brought up, which is really the societal impacts of using data, right? And right from the get-go, understand the potential ethical issues around what it is that we're doing. I think we have seen what happens. Data science wasn't really born out of academia. It was born out in industry to solve some really important problems for industry. And as a result, there's sort of some catching up and field defining that needs to happen now as data science as a field matures. And we hope to sort of bridge this gap between just extremely good hammer and nail hitting and understanding where the nails are being placed and understanding, what's the real impacts of the work you're doing. So that's the only bit I would probably augment a little bit from what, Mustafa really said there.
Well said. Absolutely. Jonathan, anything to add?
Yeah, I can add a little bit to that. I mean, I think at Trilogy, we're, the hammers and the nails are changing all the time, right? And at at the core, we're trying to teach students how to problem solve, right? And I think data science does that. It does it in a very unique way and like in a unique lens, but kind of the underlying problem solving techniques are transferable, right? Because I think that one of the things we see is we hope everyone goes on to become a data scientist one day, right? Like that's aspirational, but probably not necessarily the case, right? So, we're teaching problem solving that they can do regardless of what their professional path looks like after they engage in a training program at a university or at a boot camp or something like that. So.
All right, very good, very good. That's a good opening round, and I love all your answers. And there's some cohesiveness and trend in terms of what you see as a vision for education in data. That said, now, what are some of the basic skills, right, that you require from folks? I know, David, you attributed a little bit to some core computational foundation. So what are the basic skills you require from folks trying to get into data-related fields in terms of education, right? What do you want them to start out with?
Yeah, basic is interesting, right? Because I think that it sort of depends where the student is entering at or the person in a career is going towards, right? So when we mean sort of foundational computational statistical reasoning, sometimes we could quickly answer that question with tooling, right? So right now, the tools that I think are in high use are things like, Python and, understanding distributed data systems, cloud computing and things like this. But when I think about more of like basic knowledge, we actually, I lean much more towards what Jonathan said in problem solving, right? So we need to understand the frame we teach, even concepts like introductory probability or linear algebra or, SQL with a data forward way. So that's been very difficult, I think, for some of us old mathematicians at times to think about teaching linear algebra, where the first assignment has, a data component to it. And so, I think though, on those basic skills, you really need to be able to understand how to visualize data, explore data, understand, again, the limitations of what models can and cannot do. And really, we're starting to understand that there's no rush to modeling before one understands the bias and the distributions of data, way before you start thinking about what kind of prescriptive dynamics you want to give around a problem. I think there's plenty of foundation, like basic work there. Practically speaking, you can get most data science jobs, or at least used to be able to, if you pass just frankly a SQL exam. So there, if you don't understand how to do those things, you're just gonna have to learn them on the job. So you might as well start before that.
Right. Any other thoughts? Anyone wants to jump in on that?
Sure. I mean, I think all of us agree on the mathematical skills for sure. Like probability theory, statistics, linear algebra, even calculus and optimization. Computational skills like understanding computational complexity is obviously out there as well. I'd also add maybe the communication skills. I think from the beginning to end, the data analysis, from data cleaning all the way to presenting the results in a meaningful and understandable way. I think communication skills is also a fairly integral part of it. And during this whole process, agree with David that the data scientist needs to be grounded in ethical considerations of the whole process as well. So I added communication skills and stress the ethical aspects once more.
Right. So, and are there skills that can be learned, or is it skills that you're expecting a student to have before they come into the educational program?
It would be great if they had it, right? Before they come, I think definitely mathematical and computational skills as a basic level is definitely would be useful. We teach a lot of skills at our universities, but strong foundations in mathematics and computation definitely is great to have.
Yeah, I think, coming from the boot camp world, like what does prerequisite skills look like before you come into a data boot camp? I mean, there's essentially none, right? They're like we take people from all walks of life. And I like to say, that our entry is like, you're not scared of numbers, right? Like if you have this like phobia or fear of touching number, like you're gonna have a really hard time succeeding in this space. Like we can teach you how to calculate an average, we can teach you about distributions, right? But if you're scared of the numbers, it won't work out. We've admitted some students into our boot camp, and we've searched really hard to find those skills. So it might have been like a store manager that has done like forecasting of inventory like by hand, right? And they're able to like talk us through what that process looks like. They might not know the concepts that they're actually describing to us, but it's like, oh, they have some quantitative insight and inquiry that we could actually like build upon. So yeah, it's tough to find that, right? And it's like, what is the magic question of how you start to assess that before somebody enters a program? And it's hard, right? Like, tell me about a time you use numbers, right? Is basically the prompt that, that we can use, right? And kind of see what people say and parse out from there.
Right.
I realized, Meji, you were getting at that prereq, and I'll say at the undergraduate level, I think the entrance to UChicago is a little bit challenging as far as I've heard. But generally, be a good student. I think though what's interesting at large though is I think the biggest route, one of the alternative biggest routes to getting into data science has been more at a professional master's level. And there, a lot of the prerequisites have started to settle into about the same, I'm happy to enumerate them. There is, one class in statistics, one class in usually Python, but at least one intro to computer science class. Sometimes if you get lucky, one linear algebra class, but that's not always required. Many of these programs though do require an interview, a little bit like, it sounds like Jonathan actually has a conversation. We used to have about a 30-minute technical interview with a candidate just to feel them out. And it wasn't really about gotcha questions as much as to watch them reason through, problems. And so we felt, most of these programs end up adding a boot camp of sorts to the beginning of their professional master's program anyway, to sort of level set the field. Right. So if there is someone interested in thinking about, getting a post-bac degree in data science, I would say that the barriers aren't that high in that case. Like, so I'd encourage people to think about it.
Right. And we, I think most schools have these sort of accelerated courses that get you prepped for the data science program, like accelerated course in computer science, accelerated course in statistics and mathematics, that are sort of compact and accelerated to get started. So I think entry barrier is kind of lowered with that.
Right. No, that's very good to hear and encouraging that really anyone that can reason logically and wants to pursue sort of career and is not afraid of numbers has a path to actually an educational program that can work for them. So that's very good. Now let's take on the flip side of it and look at the end. So we're not looking at the prerequisites in terms of entering the program, but more of someone that's a fully mined or coined data professional. And I use the term data professional not to narrow down on data science, but data engineers, visualization engineers, and anyone within the data field in general, right, as a whole. So if you would call, what are your three, and then let's use the same question, 3 core skills that if someone introduced themselves as a data professional, whether it's an engineer or a scientist or any of the such, or an analyst, what would you expect those 3 core skills to be? Top 3, any 3.
Top 3. Oh. I'll let my colleagues go first when I think about
it. I guess I'll start with 3. So 1, strong theoretical background in data science algorithms, all the way from data cleaning to visualization to modeling. 2nd, can I say 4?
Just drop your 4th.
2nd, understand the strengths, also weaknesses of these algorithms. So I don't want our graduates to just do plug and play, right? Okay, here's data, here's the algorithm, I'm just going to plug and play. That is not something I'd like our graduates to be doing. I'd like them to understand the strengths and the weaknesses of these algorithms. 3 is grounding in ethical considerations of these effects that these algorithms have in society. I guess 4 that I was gonna add, if I may, is the ability, maybe skill to really learn new things, because data science field is changing rapidly. So like, and reading papers and understanding and improving yourself is a skill that I think it's not just, grab the paper and read, because it's, understanding the paper itself is a skill. And I think the ability to improve yourself would be the 4th thing that I would add, because the field changes rapidly.
Right.
I'm gonna go a slightly different route. I liked everything you said, but some of them sounded like a whole bunch of skills on one. So I'm gonna put my hat on as a hiring manager in industry, which is I've helped a lot of our students negotiate these positions and see what's attractive. I'd say you'd want to have a demonstrated record of taking a project through the entire, like a real data project through the entire life cycle. Then, so that's 1, it's just like, that level of independence to be able to do that. 2, I'd say extremely effective communication across that life cycle, not just presenting the work, but being able to talk with people throughout the process. And then if you have the ability to demonstrate being able to be an effective teammate on a technical team, those 3 things have been really sort of, I think, differentiators when people go out on the market, and be able to stand up when it's time to tell the work that you've done, show your critical thinking a bit, all of the, you get to eat all of what Mustafa said into one part right there. And says you have to be able to demonstrate you understand the impacts of your work, that you actually know how to stand up, the significant amount of piece of code to get that problem done, and that you understand the mathematical basis as to why you did it the way you did it. But then, yeah, communication, and then honestly working on an effective team. Those are really, data science is rarely done alone. So yeah.
Right.
Yeah. I mean, to add to that, I think quantitative ability, right? We've already kind of covered that one is key. And I mean, on the bootcamp side, we're all about giving folks technical proficiencies, whether it's in like a programming language or like a tech stack. But I think that depends on the person, right? It's like, what are you aiming towards, and make sure that your tech stack aligns to, if you're going to be a visualization analyst, that all the viz tools, right? Or if you're going to go into machine learning, all the tools to get you there, right? And then we really focus on like documentation of like, are you able to write up your results, communicate them, show step by step, and really like this explainability piece of what you've done. Like it's just not sufficient to do the analysis, right? But you have to be able to like say what it means to someone that doesn't know what you're talking about, right? And I think that's a differentiator for someone that can have that layperson conversation and make it really effective. Like that is a huge differentiator in the space.
Right. So it's very interesting to hear all your answers. I hear it's from a spectrum, right? It goes from a research sort of, what do you define a research data professional, to more of a hiring manager data professional, to a data professional that can do some work and be valuable to the team immediately. But it covers all the spectrum, and it's fantastic. I love it. All right, let's move on. We have so many questions and so little time. Let's see here. We've talked about the core skills that we want from a data professional. Now let's take a step back and talk about the soft skills, right? And there are soft skills that are very critical. Business matter expertise. You're working for a firm or organization, you're working within some sort of industry that requires some background information for you to be able to do your work effectively. So you have that, as well as communication. How do your educational programs address these soft skills?
I can maybe kick that off, because this is something so in the bootcamp world, the bootcamp I work on is 24 weeks, right? So we have essentially 24 assignments to teach all the skills and assess them in one go. And the soft skills is something that, harder to train around, right? You can have like a training on how to write, communication, or like how to communicate, right? But it doesn't really prove anything until they do it. One of the things we've been doing in our assignments is, rather than having students like write like a small paper or something like that, we're now asking them to write like an email. So like one of their assignments is like, write an email like describing your analysis like you might do to your manager. So we're getting the same information that we would have gotten in the like one pager, but now we're asking them to write it in email format, be succinct, that kind of thing. So we're trying to slot in these like professional soft skills. That way, if the email is formatted really weird, we can intervene at that moment, give feedback before they're doing that on the job, right? Or communicating with a hiring manager in an interview. So that's really subtle though, right? But I think that that's a shift in thinking of in terms of like, how do we embed the soft skills? Will we make the soft skills part of the education? Or are you working in groups in classes versus like working independently on projects, right? Like we mentioned earlier, like working in teams is really important, right? So can the education mirror that, right? And so we're integrating group projects and things like that to be successful in the program itself. You have to do those soft skills well to actually graduate.
I think for programs in universities, I'm actually delighted to hear about some of those. I might steal the email one. I think programs in universities that, at least declare themselves to be professionally oriented are really obliged to think about these things in a serious way. That means that you may give up one extra statistics course for a full communication course. I know we did that, right? And there, what that meant was like, not writing papers, actually, right? Like you said, it was actually, though, we would, and we actually embedded through almost all their courses requirements to blog about their work, right? And so there's sort of, and then engage in the community through that blog was part of the grade, right? Was to stand up how you're communicating in the platforms that people are ingesting data science in, right? So blogging was something that, we started to add to the communication. We also would send our students out to meetups in teams, and they had assignments at meetups to build networks and learn how to talk to people, how to introduce yourself, how to, and you had to, we sort of had this requirement that you had to introduce someone that was more senior in the field than you, broadly defined. And so, it was, and then the other people in your group watched you ask 6 questions and peer graded you. Those things are the ones that are some of the most memorable things the students, recall later in exit surveys and things that really sort of started to build confidence around those soft skills. There's a whole plethora. I mean, formal business schools, particularly like Booth, are actually great at this stuff. It's usually technically the computer science and math and more traditional other areas that are just like, no, just be smart and things will work out. And that tends to not be always the case, right? So,
yeah.
Maybe I'll add 2 more things to that. The great things that Jonathan and David already mentioned. One thing I'm sure many courses are doing this is there are projects and presentation in the courses themselves to support the communication skills. One other thing that we are doing at Illinois Tech is students have to complete a capstone project, which is a summer project in working on a real problem in teams with a partner industry. So, it has, they are working at the, it's not an internship, it's different. So this is in collaboration with a faculty member at IIT, as well as an industry, and working on a real problem as, members of at least 3 teams. 3 members of teams. And I think having that kind of experience, hands-on experience on working in a team environment on a real world problem with an industry partner has taught more than the sort of like, how do you communicate kind of teaching in class, I think.
Yeah, you're absolutely right. And I have been the industry partner in several of those key capstone projects for IIT. So yes, that is very valuable to the students for sure. So let's move on to another question right now. This is from my perspective as someone that's in the field, has built teams, worked with several data professionals, hired some, had to unfortunately let some go, be hired myself when I was younger in different positions. So the one thing that is very core is no matter how much education you have, you understand the technical skills. And we've talked about the soft skills that are critical, yes, but it needs to be practiced. It's sort of a practice learning and not something that you gain over time. And we're working towards the soft skills to help bridge. But beyond that, there's still a sense of learning what it means to work in an office. And of course, we're referring this to students that have possibly never had a professional job before, right? Coming out of college or gone through education throughout, so have never been really in a professional sense. Now they're starting to acquire some of the soft skills that are important, but they still don't really have a great concept of what it means to be an employee or part of an organization. Take, for example, if you were to do a survey of your students right now in terms of their resume, 95% of the resumes I get are covered with coursework. While that's important, it's very useless to me, right? You've taken some computer science 360 or something that talks about algorithm. I really want to see how your skills that you've acquired, how they pertain to the job that I have, and show me that you're fit for our organization at large. So my question is, what are we working towards bridging? So we talked about the soft skills. There's a leftover small gap in terms of behaving in a professional setting. How do we teach students or data professionals that sort of skills?
I mean, I think it's a hard one. I think what Mustafa said is certainly one of the takes that I've had that has made success is we, in both University of Chicago, the previous place I've worked at, we worked in an integrated way. So the students enrolled in a course that basically sat students at the desk at Airbnb's data science team and worked, right? There was sort of no way to replace that experience as it was integrated through the whole master's program. So we're doing something very similar here at the University of Chicago, starting that up, where we will be putting the students embedded as close as we can in the data science teams. We feel like, when we run a clinic at the University of Chicago, we start using the methodologies of industry, things like Scrum and Agile methods. We actually begin to work the students that way to understand what the life cycle, what does a data science sprint feel like and look like. The more that there's engagement in our industrial partner around that, the better. I do think, though, if you don't center practice in that way, you don't do the students a great service as you prepare them for professional work. In the end, they're still students, right? And so, I think that there's a limitation while they're learning all things, but the more you can front load some of those experiences, how to act. We've had as a result of doing these things, some horrific case studies of how not to behave in an office, right? Through this, right? But what was great about that, we could correct that while they're still in the program. And we had ways to turn that into a learning experience. Yeah.
Yeah, I think I'm gonna just add or repeat, maybe the capstone project has been, I think, a strong corner for that, for students to be able to learn those skills. And obviously internships, internships are a big part of having that kind of experience. And I'm hoping, that the industry also has training programs, right? When the students join, you guys are going to be training our students to your specific needs. I think this is a partner, and maybe there is some work needs to be done on making that kind of partnership between industry and university stronger on communicating with the industry, like what the industry really needs, what the university provides, and what are some gaps that needs to be filled by industry, and what are the gaps that needs to be filled by university. I think is something that we need to talk more with the industry.
Right. Yeah, that's a good point. All right. Moving on. So one other key aspect that we find, especially around tech and data, is the lack of representation, right? So how do we ensure, and this is data science and data field education, it's young and evolving, right? It's going to change 5 years from now, 10 years from now, it probably wouldn't look the same way. How do we ensure that as we're building and we're educating people coming into the space, that there is an accurate representation of the people that are in the space, cultural representation, I should emphasize, that reflects our society and our communities in particular?
Yeah, that's a really good question. And I'm sure my colleagues have a lot to say on that. For us here at the University of Chicago, that's just a principal part of the mission as we develop our data science initiatives here. It's very rare when a new field becomes available and then really sort of catches fire and becomes a very, very large field in a STEM based area. the last that we saw kind of come up in this space is software engineering. And in short, what we would like to do if we're going to define a new field of data science is maybe take a different shot at defining who becomes a data scientist and the path that software engineering went. I think it's going to be an all hands approach to this problem, and there's limitations from each of our areas and what we can do. But I think as long as we are starting with best practices around recruitment and retention and representation in all facets of our education programs, but also recognizing that there isn't going to be, that's not the path for every person, is to go through the university. I think boot camps have a really critical role in this. We're also developing a very serious portfolio of data science professional education for students that must work while they want to transition skills. And I think the more we recognize meeting students of all backgrounds where they are and have them feel welcome into this data science field, we're going to have a shot, I think, at maybe doing a bit better than the way software engineering worked out. So at least that's our hope. We're putting a lot of thought and resources in that direction.
On the Trilogy front, to share a little bit more on how we work. So Trilogy works with universities to offer bootcamp programs. So we serve as a facilitator of the program, the staffing, the recruitment of students, kind of full service. And I think a lot of so universities that we're operating in, most of them did not have a short form data offering before we were helping them do that, right? So in thinking about diversifying the field, we're really helping universities expand access to a lot of folks. Like if you don't have a bachelor's degree, right, you might not be able to enroll in certain programs to actually learn data science. So there is that that level to it. This past year, we announced a partnership. The partnership's in its first run this spring semester, but it was a partnership between Netflix and Norfolk State University to increase Black representation in the data space. And I think it's partnerships like that, where it's like industry, a university, and even an external provider like Trilogy are actually coming together to say, hey, there is a problem of representation in this space, and we need to very narrowly solve it and try to define what that is and figure out how to fix it, right? And so we've, went through a recruitment process, like giving amazing support to these students in this program, and we hope that they're hopefully, fingers crossed, going to be interns. A select group of them will be interns at Netflix, right? Which is like a gold key in data science internships, right? To be at Netflix. So I think it's more partnerships like that that actually push the field in a different direction to make it look different. I mean, I've been in the bootcamp classrooms at Trilogy, and they're quite monotone sometimes in terms of like what were the demographics of them when I step into a data space. So yeah, trying to work to make that not be the case in the future.
Mm-hmm. And I'd like to add on to that I think this kind of challenge needs to be faced from all the way from pre-K to boot camps in grad school, right? For example, we as computer science used to have, used to have before COVID, these summer camps for middle school girls for coding, right? And we have research opportunities for high school students come in and join, where we make sure the diversity is included in that, right? So I think there's so much we can do at the graduate level, but there's also so much that needs to be done even before grad level, before students get there. And it's I think David used all hands is needed on this. And like Jonathan said, improving access is also a big part of it.
Right. Wow, this is really encouraging because I see like lots of work being done in this. And as a minority person myself in this space, that brings me joy. So I'm very happy to hear that. Then moving on, we're talking about education, and we're talking about formal education, soft skills, and data skills. Let's take another turn if we can. We're in a digital age where devices and communication, it's part of our everyday life, right? From the toddler that can use my phone in no time and cries for it, all the way to my grandma that can play TikTok movies or something. There's a fundamental need for everyone, at society at large, not just data professionals, to understand some basic data literacy. Right? when using all these digital applications and solutions, we need to understand that behind them, there is some sort of data. And that data affects our lives in ways that are quite strongly very unimaginable. We can't even think. But there are some basic data literacy skills I think that's required. How do we try to take on that responsibility, right? Beyond shaping the minds that are going to work in the field, but to everyone really, that this is something that you need to understand about data and how it's going to affect you now and throughout your life moving forward.
Yeah, there's a lot into data literacy that is affecting our lives. Like the privacy obviously is one aspect of it that, and learning about that early on, because now everybody's like our kindergartners are using Zoom, and there's Google platforms and chat and whatnot, right? Starting with the at the kindergarten level, like learning about privacy, but also I think all the way going to you said our grandma. I think one challenge besides privacy that I would really want to focus on also, like misinformation and deceiving practices out there. There's so much political misinformation. There's so much medical misinformation that's causing problems in this COVID era. So I think teaching a healthy dose of skepticism of what we see out there. I mean, we are all aware of deep fakes, for example, right? A healthy dose of skepticism of what we see out there in the world, I think, is a challenge that we need to address and find ways to improve that literacy on what data is, how it's generated, how it can affect us. I think I'm kind of circling around because I don't have I don't think as a society we still have a good answer. I don't think we have a good answer on how to handle this misinformation problem yet. Facebook and Twitter are struggling with these, and community, I think, needs to be also aware that maybe you should not trust everything you see on Facebook or Twitter or TikTok or whatever. Yeah.
I'd say that you're right. It's a hard question. It's a big question. And it's almost one that's a little overwhelming in the sense that there's a lot of problems, and they get actually, and it's one of maybe the things that wakes me up sometimes a little too early in the morning thinking about is what all these new AI and data science tools can do is they mostly optimize, right? And so what that means is that can be really bad, but it can be great. And the problem is things have moved pretty quickly in that space without sort of really understanding the societal impacts. And data literacy is one of the ways, like general data literacy for society is one of the ways that you can kind of naturally push back on some of these more, I'd say deceptive and grievous examples we've seen of late. That problem was here before data science. But it's also that's not to say that we should throw up our hands and say this is unsolvable. One of the things that I think is really exciting to see, and it's because I have young kids, is computing literacy, right? So now my 7 and 8-year-old and 9-year-old, right, as they're getting older, they've been coding as part of like a normal part of first grade, and they were in public school in San Francisco for a while before moving here, and the fact, like, that was something that didn't happen when I was a kid, right? And so there's this general sense of being more computationally literate, and I'm looking forward to some of the curricular changes that are going on that are catching up around computation to also maybe drag along some data literacy with it. But there is certainly proposals of including really basically what I would call a data science curriculum at the high school level now, right? And trying to fit that into different places of the curriculum. These things are hard, but the more education itself is one of the great antidotes to some of these problems. And I think keeping our curriculum up to date in that respect has an opportunity, but we're not there yet, I don't think.
Yeah, I mean, to add to that, right, like data literacy, I mean, goes back to like numeracy, right? Like, can you just reason with numbers, right? Which is kind of like the precursor to the data literacy problem. I think on the education front, like, David, you were mentioning, it's like there are tools like Scratch right now, right? Like kids are learning like how to think algorithmically, right? They don't recognize it as being algorithmic thinking, but they're like acquiring that like base kind of knowledge, right? And those tools are actually being slotted in. It takes a long time for like the K-12 curriculum to change, but it's really easy for a tool to slide into a classroom, right? So I think like one of the ways that we actually address it is giving teachers the tools to teach these ways and patterns of thinking, which will evolve much quicker than the Common Core standards or anything like that in the K-12 space.
Right. So what I'm hearing from you all then is this is something that needs to be embraced in our educational system and should start from as young as possible.
Right.
Sure. And as old as possible. I actually think, I don't know how your conversations go with your folks, but, I do wish that there was more opportunities for people to be learning at all aspects. I think the lifelong learning programs that universities have are great. I think just, thinking about how that education is really a lifelong process.
Right, right. Very well said, guys. One of the responses from the last question, actually, let's delve into that a little bit more deeply. We talked about the effects of data literacy, right? We talked about security, privacy. So let's talk a bit more about ethics, bias, and trust. These are core tenets that we see playing over and over as very significant role with regards to applications of data solutions that we build or we help students and educate students to build. How do we ensure that our training programs have these tenets woven within their fabric in a manner that someone is thinking about all of these things when they're building a solution at all times?
That's a hard one, but it's the right question to ask, right? I think my take on this is to approach that entire question and field with a lot of humility. I think as an applied mathematician, I like to fall back onto mathematical reasoning as almost a crutch or just a base of where I understand the world. But I now am convinced that it is just a part of what it means to become a really good data scientist for the world, right? An ethically minded, a society mindful data scientist. Here, because of the limitations of my own knowledge, we must, at least at the university level, come at that particular problem with everyone at the table. And I mean social scientists, our colleagues in law, and philosophy. There is great, the good news is that it's not starting today. There's been some really incredible work being done by people in this space. And, the more one scratches the surface of these problems, the more one sees. I view this field as kind of studied in two ways and solutions approached in two ways. One is people are thinking about 50 years down the road about the impacts on society of automation. Okay, that's a really great problem. But to get back to the question you have around like putting people out there now, I'm much more concerned with the harms that are occurring right this minute, like in vivo, right? We actually know that there's, very serious ethical violations, frankly, of work being done across the sector. And a lot of the time it's done out of just pure ignorance. So that's where we have to step in and really provide really serious training for educators. That means, and this is the hard thing one has to say in rooms, is to provide enough space in the curriculum and resources so that's meaningfully addressed. It cannot be sort of just something taken on the side or you attend a talk while you stay in your machine learning classes. It's really got to be built into the curriculum in a holistic way. This is what we're going to try to do here. It's the harder way to do something, but I think it's the correct one in this case. I'm optimistic we're going to get a lot of good things right and learn as quickly as we can from things that aren't working in this space. This is more important than making sure that they're sufficiently optimizing the algorithms they're using.
Right. Well said.
Yeah, adding to that in terms of the holistic approach, I think that's what we also are trying to take. And we are learning from the mistakes of the past, in computer science and software engineering, like David mentioned. there's an ethics course, but having one ethics course, just to cover your bases is not the right strategy. And I think the whole ethics concept needs to be woven into all of the courses, and that's the strategy we are also trying to take. Take computational complexity as an example, right? In computational complexity, there's a course on computational complexity, but every computational course also talks about the computational complexity of the algorithms that they use. So you don't say, oh, there's a computational complexity course, we're not going to talk about complexity of this algorithm in this course. Right? That's not the approach we take. Right? Every course has to talk about computational complexity. Similarly, ethics needs to be discussed in every course, in every data science course, because ethical considerations for a machine learning course is different for ethical considerations in a computer vision course, right? Or in a natural language processing course. In computer vision, you need to think about face recognition as well as deepfakes. In natural language processing, you have to talk about fake news and misinformation. In bioinformatics, you have to talk about ethical issues in medical. So I think having one ethics course is not the right approach, but having ethics discussed pretty much at every course, like computational complexity is integral to computation. Ethics needs to be integral to data science.
Yeah, I mean, I would agree to that, right? I mean, in the bootcamp space, we have this tight box of curriculum. It's always like what's included, what's excluded kind of things. And lately we've been having conversations like, well, we need an ethics box to put into that package. And it's like, no, you should be talking about ethics every time you build a model or you run an analysis, right? And, there have been examples in our curriculum over the last year where we've rationalized and saying, there is bias in this, right? Like maybe it isn't being approached correctly. And it's like we need to leave those in the curriculum, right? But make them a talking point, right? That there's like an ethical juncture that you have to discuss. Like that's how learning happens in this space, right? As you see an example, you call it out for what it is, you address it, you move forward. I think the thing that concerns me more is having the right skill set of in the bootcamp world, distributed classrooms, right? Many people, teaching a set curriculum, not everyone is prepared to have a conversation around ethics with students, right? We're not all ethicists. And these are tough conversations to have, right? And I think one of the big pieces for me is like, how do we actually support someone once they've developed like an instructional relationship with someone where they can actually feel confident in having that discussion with students? And I think we get to address the ethics by like preparing the folks teaching and leading these courses so that they can actually have the conversations with folks. So it's trust and confidence building that gets us there.
Right. That sounds really very good, like actually a good way. And I really like the idea of weaving the trainings, the learnings from the ethics, bias, and trust into every class, right? So then an example, whether it's mathematical, you're doing some linear algebra, I'm like, what's an application of this? Whereas dimension reduction, is there any ethical considerations, right? And have everyone discuss and think about it. What about trust? And basically have the students start to think in that manner in terms of every application that they do as part of this training. I think I like that. That's very good. All right. We're almost running out of time here. I think we have time for 2 or so questions, maybe 1 or 2, we'll see. So where do we see, I think this is going to be the last question, given time. Where do we see the data profession in 5 years from now? 10 years from now? Would professionals be doing the same sort of work? Would they need the same sort of skills? How would they have changed? What are your thoughts on that?
Can we see 1 year in the future? Like last year, COVID happened and everything changed.
A remote. It's going to be a remote. Who said it was going to be remote next year? Yeah, go for it. I have some thoughts on this, but you should.
Yeah. I'd say so many of the principles are still going to be here, right? Deep learning sounds new, but neural networks date back to 1943, right? Deep learning training used an algorithm called backpropagation that was invented really in 1975, right? So many of the principles and background, technical background is going to be still here. However, a lot is new, like, so much data we have, right? Compared to 1975 when backpropagation was invented, I don't know what the memory size then was, right? I remember floppy disks. Many of my students don't know what floppy disks are anymore. So there's so much data. We are generating so much data. We are storing almost all of that, maybe all of it, all of that data. So there is GPU computation data. I think those are some things that are different from 1975 when backpropagation was invented. So I think that's why I think data scientists needs to be, grounded in theory, which changes much slowly over time, but needs to be agile and have the skills to. I'm going to repeat myself saying that they need to be agile to read scientific papers and learn about new concepts and discoveries as they go, so that maybe these data scientists need to update themselves as much as they update their software and computer on that and new concepts. But on a fundamental level, many of the skills that they're getting now are going to be relevant, I think, in the near future for sure. I'm going to stop there.
5 years, man. If you asked me that 5 years, I would have gotten this wrong already. I think what we've already seen is a field that has renamed itself several times, not splintered, but maybe defined more narrow subfields that are starting to change less frequency. I remember when data engineering became a thing, like 6 years ago, 7 years ago, maybe, as like a title that took off. People asked the question, well, what does it mean to be a data scientist in the context of data engineer? Now there's MLEs, and now there's research data scientists, there's data science around product. I think those types of things still have a lot of movement. I think the tooling the platforms that are being developed to do data science is opening up more people into the field than when you used to write everything from scratch. And that can be quite a good thing. I think one of the other parts of the field that's really I've been fascinated by that isn't often talked about is how data science is done from a business perspective or an industrial perspective. What is the structure of a data science team? What is an effective management structure around data science? The platoon method, the embedding of data science, the internal consulting version of data science. I think those things have not even proved out. That we've seen great successes and failures of all sorts of ways data science is structured inside a company. I think this means that there's a lot of ways to get our guesses wrong. My short answer is I have no idea what it looks like in 5 years. I think though there are some things, theory is a scary word, but I maybe soften it to say you got to be a really good problem solver. I think you need tenacity in regard to computational fortitude, as well as math, model, and I won't even use the word mathematical. I'll say reasoning with models. I do think that the biggest change where it's actually impacting bottom line is really understanding how to integrate ethical. The chief ethics officers now that are being hired at quite a clip. I remember working with a company that was going to IPO, and the project we worked on was to sort of clean up a lot of the stuff going on under the hood to see, as you become a public company, what kind of are we doing the best? Are we having best practices around our data use, right? Data governance, which has been a place that really has had no explosion in education, is a serious set of questions I always get, and the ones I'm like, gosh, that's a good question. There's not a lot of people thinking about data governance, and it's such a big deal for companies. So it's just to say that we're still at the beginning of a field, and I think that's exciting, but it also makes it really hard to guess. So.
Yeah, and I'll venture one more really wild guess, right? I think that things that used to take a really long time and like really complex, like people can just do them now, right? So I think in 5 years, like you're going to have someone sitting in an HR team that's actually generating models, right? There's almost like this proliferation of mini data scientists that are going to be running around in organizations that are not classically trained data scientists. So I think we have to prepare for this like data adjacent role that's actually really powerful. I mean, that is a whole new question of how we would train someone like that, right? Because you're pairing like subject matter expertise in an area with data. but that would be my guess as to,
Right.
data takes over the world, right? I think is the simple conjecture there.
No, you guys are bringing really great points. And for my part, I think the way I think about it is maybe 15 years ago, all the rage you were quant, right? A quant or modeler. That was a sort of synonymous term back then, was in data science. How has that changed from that role back then to now? The one key thing I can say is more tools, right? In terms of the way a quant functions to the way data scientist functions is you have more tools at your fingertip. And you guys are absolutely right. I think there's going to be more proliferation of tools and to make the skill sets more democratizable, if that's a word, so that everyday person, analyst can sort of do data science type of things, and which is great in terms of more people learning and being able to do better things. However, the downside of that is you're putting powerful engines into the hands of people that really don't understand what's going on underneath the hood. Right. So there's that possibility of creating a lot of damage as well.
And when you said tools, I know we are almost out of time. I think in the past, for example, for data science, in engineers, there was MATLAB, right? And it's not open source, but now we have so many open source. I think the open source revolution really changed the data science field a lot. TensorFlow or scikit-learn, whatever, all these open source Python packages, or I think that changed the science field a lot, and I think maybe it democratized, in one sense, the field. I hope nobody is from MATLAB who's attending this meeting at this moment, but anyways.
That's fine, but yeah, you make a great point, and absolutely right. You don't understand how many data scientists I meet, and whenever they see a problem, they want to apply TensorFlow, and I have to calm them down. Yes, it's exciting and it's a hot thing, but really no, just run a logistic regression.
Right. Yes.
Yeah. But this has been fun and very exciting and insightful. It was lovely to talk to you all, gentlemen, today. I'm sure the audience is going to get a great peek out of it as well. And I want to thank you again for agreeing to be part of this panel.
All right. Well, thank you very much.
Thank you as well. Yeah.
Have a great rest of your weekend.
Thank you. All right. See you.
Bye.
Bye.